Today's conic section is ellipses. Now I drew a couple of ellipses here, and when we talk about ellipses, just like we did with parabolas, we have to talk about both directions, a horizontal ellipse or a vertical ellipse. Now there's a couple ways that you can think about ellipses. You can think about an ellipse as being a circle that's been flattened, or you can think about the ellipse as actually being two parabolas that happen to meet at these points. Either way of thinking about it is just fine. But for these ellipses, we still have a center, and we still have these vertices on the outside. They're called a major vertex, or major vertices is the plural for that. And then you'll notice that inside here we have a focus, but we actually have two of them. When we refer to multiple of those points, we call them either foci or foci. Both are acceptable. We'll talk about that. And then this line that connects the foci and the major vertices and the center is considered the major axis. Now, if you're thinking of these as parabolas, that would be your axis of symmetry that's cutting it in half. But then where everything meets kind of here in the middle, this other axis is referred to as the minor axis, and we have two more points that we identify. Now, sometimes they refer to it as a minor vertex, or sometimes they refer to it as a co-vertex. Either of those are acceptable as well. But that's the major parts of the ellipse. Now, down here, I marked a few other things. Now, we talk about the major axis. That's this blue one. Notice that it's vertical now, because we're dealing with a vertical ellipse. And the minor axis. But when we talk about its length, they throw in this A and this B. You'll notice that the distance from a major vertex to the center is A, so if I have two of them, that makes 2A. That's my major axis. And you'll notice that the distance from the co-vertex, or the minor vertex, to the center is labeled as B, so if I go the full length of that minor axis, I'd have 2B. But the curious one are these foci that are sitting here. The distance from the center to a focus is C. Now we need to have a way of calculating this C. So here's your calculation. Now it should look kind of familiar because it's very close to the Pythagorean theorem. A squared plus b squared equals c squared. But it's just a little different because we're actually subtracting to figure this out. So this is the one calculation we may have to do when we talk about these ellipses. The other thing I wanted to talk about, because it comes up time and again, is this idea of eccentricity. Eccentricity with an ellipse is its roundness. How round is your ellipse? Perfectly round, which is actually a circle, has an eccentricity of 0. And the way I keep them straight is the 0 kind of looks like something that's round. As we start squishing these ellipses, whichever direction we squish them, they get flatter and flatter, and they look more like a 1. So that eccentricity would be closer to 1. We're not going to calculate this, but it is something that we talk about as far as how round an ellipse is or how flat an ellipse is. So let's get into the characteristics for both the horizontal and the vertical. We'll start with the horizontal. Now the first thing I want you to notice is x is listed first, and there's an a squared underneath it. The a squared is actually the bigger number. So sometimes they'll try to fool you by switching these around. Look for the biggest number. That's what tells you which one is in charge. B is actually the smaller number. And there's a few familiar things in this. You have this HK. That's my center. That hasn't changed from the parabola or the circle. We have major vertices. So similar to the parabola that had a vertex, this has major vertices, 2 of them. And since the bigger number is underneath the x, I'm going to change x. If you looked at my video that had to do with parabolas, we talked about who's in charge. I would say on this one that x is in charge because x is what's changing here, and it comes from this value down here. Now notice we're using a, not a squared. The minor or co-vertices, that's what y gets to deal with. And notice that that b is sitting underneath y. So from the center, the y portion changes. We add b and we subtract b. So we go up and we go down b, we go left and right a from the center. The only thing we usually have to calculate has to do with the foci or the foci. Since x is the bigger one, since x is kind of running the show, since this is a horizontal ellipse, we're going to change the x portion. So now instead of adding and subtracting a like we did for the vertices, we're going to add and subtract c to get those foci. So I might have to do that calculation. Now, here's kind of a picture of those points that I had. Here's my center. If I add a and I subtract a, I get my major vertices. If I add and subtract b to the y portion, I get my minor or my co-vertices. And if I add and subtract c, I get to the foci. Now, when we change gears to the vertical, a few things have changed. The center has not. But notice that now, where my y and my x are sitting have changed. Instead of the bigger number being under x, the bigger number is now underneath the y. So that's how we know this is a vertical ellipse. That's how we know that y is in charge. So this ellipse is going to sit up and down. Sometimes I'll refer to this as the egg ellipse because it's standing up. I'll refer to this as the football one because it's laying down. But the center hasn't changed. But how we get to the major vertices, since y is now running the show and has the bigger number, we're going to add and subtract a to the y portion instead of to the x portion like we did over here. That means that the minor or co-vertices, the x is changing, adding and subtracting b to the x portion of the center. And for the foci, again, y is in charge, so we're changing the y with that c value. We may have to calculate that to figure out what c is, but we're adding and subtracting that to the y portion, so we're going up and down c. And again, here's a picture if this helps. Here's my center. I go up a and down a to get my major vertices. I go right and left b to get my minor or co-vertices. And my foci, I go up and down c to get their position. Now let's take a look at some examples using both the horizontal and vertical ellipse equations. Let's start our examples with a very basic ellipse that's centered at 0, 0. Notice there's no parentheses here. That's how I know that we're starting at 0, 0. I'm going to go ahead and mark that down. Now I need to figure out which one of the variables is bigger here, which one is sitting over a bigger value, so I know if this is a vertical or a horizontal ellipse. The bigger number is definitely underneath y, so I now know that y is running the show here. This is a vertical ellipse, or an egg-shaped ellipse. So when I talk about my major vertices, I'm not going to touch x, but I am going to change my y. I'm going to add and subtract something to the y portion to go up and down. That means my minor, or my co-vertices, I'm going to add and subtract something to the x and not change the y. I'm going to go left and right, but not as far. And for my foci or my foci, again, y is running the show here, so I'm going to add and subtract something to the y portion to figure that out. Now all I need to figure out is what my a, my b, and my c are. My a is going to come from here. Remember, that's a squared in our equation, so that means a is 5. And my b is going to come from here. And again, I have to square root that, so my b is 3. So my major vertices, I'm going to go up and down 5. My minor vertices, I'm going to go left and right 3. For the foci, I said this is the one calculation you may have to make along the way. So let's take my a squared and my b squared. So I've got 25 minus 9. So I need to figure out what that's going to be. That gives me a c squared of 16. That means my c is 4. So I'm going to go up and down 4 for the foci. Now, if you're more of a visual, let's draw this out and see what it looks like. So I'm centered at 0, 0. I'm going to go up and down 5 to get my major. I'm going to go left and right 3 to get my minor, and that's going to give me the shape of this parabola. So it is an up and down or an egg-shaped parabola. And just like the parabolas had the foci on the inside of the parabola, my foci should end up on the inside. So if I go up and down 4, my foci sit inside my parabola just like they should. If you are visual, start with the visual and then write these. If you want to write these first, do the visual. It works either way. Now, sometimes they'll only give us some limited information. They may give us a lot of information, but they haven't given us a picture or an equation. And they're going to ask us to do those things. So this one is also centered at 0, 0. They gave me one vertex and one co-vertex. So I'm going to attack this one a little differently. I'm going to draw this out. Because they told me where it's centered at. They said there's a vertex at negative 6, 0, which tells me there's also one at positive 6, 0. And there's a co-vertex at 0, 3, which tells me there's also one at 0, negative 3, all because I'm centered at 0, 0. This kind of looks like a football-shaped ellipse, so I'm going to talk about x being in charge. Now, I didn't put anything in my parentheses because it's centered at 0, 0. But I need to figure out what this distance is. I went negative 6 and positive 6, so that's a distance of 6. That's my A. That's my major vertex. But I have to square that when I put it into my equation. And we went up 3 and down 3, so that's my minor vertex. That's my B, but I have to square that. 3 squared gives me 9. So there's my equation. The only other thing they may ask for is the foci. But now that I have these two numbers, I can do my one calculation. 36 minus 9, which is 27. Square root that. And you can leave it as a square root if it's not one that you can do. But again, x is in charge here. So I'm going to add and subtract that square root of 27 to the x portion. Square root of 27 is roughly 5 and a little more. So if I go 5, I'm still safely inside that ellipse. Now, here they gave me some different pieces of information. Here they gave me the foci and the vertices. But you'll notice it's the x's that are changing. So this is another example where x is in charge. And notice that positive 12 and negative 12 is all centered at 0. So again, we have something centered at 0, 0. We know x is in charge because x is changing for the vertices and the foci. I got all of that from those two pieces of information. I'm just missing the bottoms. But this is the vertex, the major vertex. So if I square that, that's actually my A. A is 13, and C is 12. So I have pieces again. If I go back to that equation of C squared equals A squared minus B squared, I have some pieces. I have C, I have A, I'm just missing B. So I need to figure out what B is. So I have 144, I have 169. So if I do this calculation, 144 equals 169 minus B squared. I got to figure out what B is. So I'm going to solve this. The negatives are going to take care of themselves. B squared looks like it's 25. This makes sense. X is definitely in charge. It has the bigger number. So this is football shaped. I calculated B. If you need to see the visual, we're centered at 0, 0. We go 13 in both directions. We go 12 to get to the foci. And we go up and down 5 to get to those co-vertices. So let's put all these pieces together. Let's take one top to bottom. Here's the equation, not centered at 0, 0 anymore. Let's find all the pieces and let's come up with a graph. So this is definitely centered, did it backwards, 2, -1. I got the x coordinate from there, I got the y coordinate from there. So everything's going to build off of that center, which is at 2, -1. Now I need to find all the vertices. I see that the bigger number is underneath y, so when I talk about my major vertices, I have to change the y portion. That means my minor or my co-vertices is going to have something to do with the x portion. And my foci, since y is in charge, I'm going to have to add and subtract something to the y portion. So let's figure out what we have here. Y is running the show. Here's the biggest number. If I square root that, I get a 6. 6 is my a. It goes right in here. That's what's changing the y portion. From my center, I'm going up and down 6. My co-vertices, my minor axis, is built by this number. So if I take that and square root it, I get 5. I'm going to go left and right 5 to get my co-vertices, my minor vertices. Here's the one I probably need a calculation for. C squared is a squared minus b squared. So I need to subtract those two things. 36 minus 25, that's 11. So c is the square root of 11, which is somewhere between 3 and 4. I put that in right here, and I have the location of my foci. If I'm more of a visual, I probably want to see this graph. So we are centered at 2, -1. I pulled those numbers out of there. 2, -1. There's my center. From there, I'm going to go up and down 6. And I'm going to go left and right 5. So this is a very round ellipse. Its eccentricity would be closer to 0. But it's still an ellipse. And my foci, I'm supposed to go square root 11, which I said was somewhere between 3 and 4. So if I go up 3, down 3, they're somewhere in here, inside the ellipse where they're supposed to be. And there's my ellipse top to bottom, both graphically and algebraically.